Hello everyone. In this video we are going to focus on lab 6 of the aerospace or mechanical lab course. In this lab we are going to start learning about the ANSYS software. The reason I've chosen ANSYS software for these labs, these three labs, consecutive labs, is because ANSYS gives us a lot of different capabilities, and this is essentially a multi-physics software, and it's also freely open available to students, so you don't really need to buy a license to learn this. And this is also used in the industry very much, right? So the first lab is going to focus on how to build a geometry, how to build a CAD model in ANSYS, and then for the second lab of this series of labs we are going to focus on computational fluid dynamics, and then or computational mechanics, and the third lab we are going to do the other one. Essentially one of the labs is structural mechanics, structural analysis. One of the labs is fluid analysis. The first one is just geometry building and understanding how to build a geometry and becoming familiar with the software, essentially. So the first thing you want to do when you open your Windows is to open the Workbench software. Just go to search for Workbench. This pops up. There are two workbenches that ANSYS gives you. One is called Reaction Workbench, which is essentially a workbench that includes reactions. We don't really need that. We want to open just the regular workbench. So the first step that you have to be mindful of. When you open the regular workbench, this is what you're going to see. You're going to see your workbench essentially right here in the middle. On your left, you have a list of modules and systems, pre-built systems that you can actually add to your workbench and work with. To add any module to your workbench, you just have to drag and drop it. Pretty simple. And you have it in your workbench. Our focus today is on the geometry. So we want to start by building a geometry. And the geometry we want to build today is just a traffic light beam, and we want to put this in a box and essentially put it through wind and see how the structure reacts, how the fluid movement is around the support mechanism that we have. Okay, so for this you just have to go drag and drop the geometry. I've already done this, so I'm just going to delete the second one. ANSYS has three different geometry or CAD softwares. If you right click on the geometry, you're going to see these three different. It says one is called Discovery, one is called Space Claim, and the other one is called the Design Modeler. Design Modeler is the original ANSYS CAD software, and I use this one, and we're going to learn about this one, but the Discovery is the newest one. These are very easy to learn. The only reason we use Design Modeler is because I've been using Design Modeler for a while now. So just right click on it. I already have the Design Modeler open right here. That's why the options are grayed out. But just right click on the geometry, open the Design Modeler, and then this whole thing shows up. The first thing you want to do is you want to check the units. See, the units is in meters by default, right? You can also change the units from the option right here on top. You have a couple of options on top here. One is create, using which you can do a couple of operations, CAD operations, extrude, revolve, sweep, and add a skin to your whole system. You can do a lot of transformations. You can actually create primitive objects that we are going to use, right? There is a concept tab that can create lines from points, edges from lines, and so on and so forth. If you actually import your model here, you have to work with this tab. There's a tools tab. These are your run-of-the-mill options that you can find in any CAD software. The unit and the view tab. Okay, so what are we going to do? And there's like all of these other options that we're going to get to hopefully soon. Okay. What we're going to do today again is to build a traffic light beam and just put it through wind, right? So to do so, we have to build the beams first. Okay, so you come here, you go to these primitive objects, which you just want to create two cylinders or two boxes, doesn't really matter. In the lab instructions, it says you can actually sketch a box and extrude it. In this video, I'm going to use the other way, which is somewhat easier. So you can just choose a cylinder, gives you a cylinder here, and your cylinder has its height in the z direction and is on the xy plane. Okay, we can change the direction that you want to look at, like this. Okay, you can change the planes. You can do a lot of things, right? Just by playing with these options right here. But how to build this cylinder? This is just your default thing that pops up. You come here, you have a lot of options. You can name your cylinder. You can call it cylinder 1 or beam 1. This is supposed to be the vertical beam that holds the whole structure. You can change the plane. Just click on this. You can choose a plane or choose a plane right here and change it. We want this to be on the XY plane, so we are not going to touch this. You can change how this is being built. Like when you choose add material, what happens is if you add a second object that somehow shares some parts of its body with the current object, they are going to be unified, right? Without the need for any further operations, right? So this is fine when you just want to add the beam structure, but later on when you want to build the control volume that should contain the air surrounding this beam structure, we need to change this to add frozen. You see the two options here. Well, you're going to keep the add material, and then the other option is asking us to essentially tell the software how to build this. We can build it based on coordinates or based on selections. We're going to keep the coordinates because we haven't really defined any points here. So the x coordinate origin is 0 meters, y coordinate origin is 0 meters, z coordinate origin is also 0 meters, and then it is going to move 0 meters in the x direction, 0 meters in the y direction, and 1 meter by default in the z direction. I'm going to change this to 10 meters because we want to have a 10-meter line, 10-meter line beam, right? And then the next step is to choose the radius. I'm going to change this to 0.5 or 0.25. I think 0.5 should be fine. So 50 centimeter radius for this beam, and it is in the z direction. Okay, so we are ready to build this. To build this cylinder, you just have to click generate right here, and you'll be done. So we want to add another cylinder that is perpendicular to this. So the job of this other cylinder is to actually hold the lights. Right? Come here, do the primitive thing, and cylinder again. So the plane here is going to be different. See, it's right here. We don't want this on the XY plane. We want this on the ZY plane because we want this to be perpendicular to this whole thing. Or the ZX plane, that doesn't really matter, right? So let's change the plane. I wanna choose the YZ plane. See, it changed the direction. You don't really need to do this. It makes your whole thing easier. So the starting point for this one is 0 in X, which is fine, and 0 in Y, which is also fine. But we have to move it up on the Z direction. So I'm just going to choose 9.5 meters in the Z direction. Okay, and then how long it's gonna be? It has to be we want this to be in the X direction, so this has to be let's say 10 meters in the X direction. I think that these directions are a little messed up. I think because I chose the YZ plane. Let me actually change it back to XY plane. See, yep. So if you just go by the original plane, there won't be any mix-ups. Just go by the original plane, and we want this to be 9.5 meters in the Z direction, and then we want this to be 10 meters long with a radius of 0.5 meter. Hit generate, you have your beam structure. Okay. We can also see it in different directions. Let me I want to we can also use mouse. I'm gonna use the mouse for this. I'm sorry, what is going on? Yep. Okay, so I want this to be in the YZ direction, like this. XZ direction. So this is our beam structure. We just have to enclose this with a box. This box is going to act as a control volume. Essentially, this is the box in which air is going to move in, right? So this box has one side of it is essentially going to be just a ground and needs to be connected right here. So one side of it has to be on the XY plane, but the rest of it has to be bigger than the beam. So we're just going to essentially create a box that is 20 meters in each direction. Okay. Go to primitive here again, create a box. Here you have to choose add frozen. Why? Because we do not want to combine the box with this. Right? We just essentially want to subtract this beam structure from the box. So as far as the air is concerned, this is it is going to see this beam structure as a boundary. Okay. So the coordinate points, again, I said we want to have this. See, this is the default box by right here. We want to have this 20 meters from each side, except for this Z coordinate. So I'm going to start from negative 20 meters in the X direction, negative 20 meters in the Y direction. And like this, and Z meters in the Z direction. So I also want it to be 40 meters long, essentially from this negative 20. So this is going to end up here in the X direction. See, and also 40 meter long in the Y direction, but only 20 meters long in the Z direction. So this is our box. It's upside down, but you get the idea. Yep. Like this. We don't really need to do anything else. We just have to hit generate and be done with this. So you have your box and you have your beam structure. The only other thing we need to do here is to remove this beam from the box. So essentially create a cutout. There are other ways to do this in this software, but just wanted to make sure that you see the Boolean operations. So it is in the create. It is not grayed out anymore because we have a frozen body. So you click Boolean, you change this to subtract. Our target body is this big box. Just click and apply. Our tool body is the beam. So I'm just going to click here, and this gives me the option to choose one of the two bodies. We don't want to. Our tool body is not supposed to be this control volume. It's supposed to be the beams. Apply, and then generate. So we essentially have a cutout of our beam that is held within the box, which is the control volume. And we are going to have air come in from this direction and go out from all the other directions except for this. So this surface is going to be our ground. This is going to be air inlet, and the rest of the sides and everything are going to be outlets of air. this is essentially what you need to do for the lab. For this week's lab, you need to build this in the A018 room, where we have a lot of computers. We have like 12 computers there. You just have to go there, build this, and upload the file to Blackboard. Just save this file, or save project essentially, or you can just export the file as a design model database, right? Just save this and send us this file. There is no need to write a report or anything. Okay. Have a good day.